Hello, and welcome to our presentation of our project Voterboard, a blockchain based voting application. We are Team Ethereum. So, these are our team members. So, let's start with the introduction. So, the problem with current voting systems is that there is the possibility of tampering of votes and henceforth a lack of transparency. So, the advantage of using a blockchain enabled voting application is that it improves security, ensures transparency, and also makes the system more accessible. So, in this project, our goal is to build Voterboard, which is a blockchain based voting application. Some of the key features are we are using smart contracts to ensure secure voting and recording of votes. We have different roles for users like admin and voters, and overall, we want to provide a more transparent and auditable experience of the entire election process. So, what are our goals and objectives? Our main goal here is to create a full stack voting application that is essentially based on blockchain technology. We are using a combination of tools and technologies like React for front end, Solidity for writing our smart contracts, Ganesh, and Truffle. Our ultimate goal, once again, is to build a reliable system so that we can give a proof of concept that such systems have the possibility of working in the real world as well. So, what are the functional requirements for our application? So, first and foremost, it's user authentication and roles. Giving different roles is very important so that we know who can handle the elections, who can vote, and who is not authorized to access any of these features. Then we have an admin dashboard where you can manage voters, where you can manage candidates, and where you can see the results. Then there is the voting process itself, which allows users to cast a vote. Candidate and voter management, again, adding voters, adding candidates, making sure that no one who isn't authorized is voting or no one is voting even twice. And then we have data display, which displays the list of candidates and respective number of votes that they have achieved. And last but not least is our user interface. Our goal is to make sure that we have a user friendly application so that it's easy for users to use. Some of the non-functional requirements that we have tried to cover in this application, first and foremost, is the inherent advantage of blockchain, which is security and immutability. So our application does support that. Second of all, as I said, user experience. It's a great experience working with this application, going through the different flows, and it's accessible on different screens. Reliability and availability. So we have protocols in place which ensure that this voting system can operate throughout the election. There are, uh, I would say that error handling in place which can help us in this area. Last, auditability and transparency. So we are adding features that will allow everything to be publicly traceable through the blockchain so that it can be validated for a democratic process. What is the system architecture like? So this is an application flow diagram, I would say, for our system. So the user starts at home.js where they are assigned a role using MetaMask. Depending on if they're a voter or an admin, they go to the respective React pages. If they are a voter, they register their vote, which is sent to the smart contract. If they are admin, then they can add the candidate and voter info and the election state, which is sent to the smart contract. Smart contract processes this information and then writes it to the ledger. The smart contracts are written in Solidity, and for migration tracking in Truffle, and the ledger is supported by Ganesh, which is used to create a local blockchain network, which simulates the real world Ethereum network. And all after the data comes in, admin.js page can also get the live results and the final results of which candidate has got which votes. So that data is retrieved. We have two smart contracts written here. One is migrations contract, which is mainly used for migration tracking in Truffle, which is the Ethereum development environment. And the second is voting contract, which is the most important one, and that has all the functionalities implemented for managing candidate information, voter registration, and the entire voting process. We have two roles in this application, so you can either be an admin or you can be a voter. Admin is responsible for managing the overall process. They can view the results, they can add voters by specifying their metamask addresses, and they can also add candidates. They are the ones who are responsible for starting and ending an election, and before start and after end, voters cannot vote. Talking about the second rule, which is the voters are registered using their MetaMask addresses, and their only role in this application is to cast a vote for their preferred application. So we have deployed our smart contracts using Infuria. It is a platform that provides infrastructure and tools to connect developers' applications to the Ethereum blockchain without having to run our own nodes. So we have used the Sepolia network, test network, for our ledger, and we updated our truffle config files to make sure that we were able to migrate our smart contracts to the network. And once these contracts were deployed, we verified to make sure that they had the right verify and publish section at etherscan.io for the Sepolia test network. So what were the challenges that we faced in this application? First one is complexity in smart contract development. So this was our first time working with Solidity, so we were not familiar with the process of writing contracts in Solidity. Second was a lack of external resources apart from the official documentation, which made a learning curve slightly steep. We faced some issues with deploying using Infuria, like we were not able to get the configuration and connectivity right the first time. We also had some trouble integrating React with smart contracts, but then we were able to take care of that. So to overcome those challenges, what we did first and foremost was intensive learning and upskilling. So we went through a lot of documentation, a lot of resources to understand how we will be able to build such an application. Second, we worked with Remix IDE that helped us better understand smart contract development and test our contracts. Then we worked with smart contracts in a modular fashion. So we simplified our contracts in such a way that we were using functions and structures wherever possible. And obviously there was the collaboration effect where all of us came together, all team members, and that helped a lot with solving problems, pair programming, and those kind of things. And last but not least, iterative development and testing. So as and when we kept testing our product and there were some of the other changes or bugs that we caught, we would update them and have a new product ready for the next iteration of testing. What we believe we can do in future is first and foremost, we can display the voting results to voters as well. So due to time constraint, we were not able to implement that in the current stage. Apart from that, we could also add accessibility features according to ARIA guidelines. We can have reporting functionalities, more stronger encryption and authentication mechanisms. We can integrate scalability and performance optimizations if we want to deploy this application at a large scale. So these are just some of the ideas that we have which could be used in future to make this a better application. So these are the contributions by our individual team members. So thank you. We'll now move on to the live demo where we'll see our product in action. Before we go to the main application, I would like to show our network that we have set up in MetaMask. So the network name, as you can see, is Voterboard, and the RPC URL is what we get from deploying it to Sepolia. So this is our RPC URL and the chain ID and currency symbol. So we have already saved this network. So now let's go to the application. Yeah, so right now I am in the admin view. We can see from MetaMask that this is my admin user ID. So I can see my admin.js page where I can add new voters and I can add new candidates as well. So let's say I want to add a new voter. So I have a voter mask id sorry metamask id for one of the voters. I'll put that id here and I'll click on add voter. I'll confirm the transaction. Yeah, and it's done. Now let's add a new candidate. So let's say Visaj. And we already have two candidates from initial contract that we have deployed. But so this is going to be a third candidate. Add candidate. Confirming the transaction. Yep, it's added. Now we are going to start the election. Admin has this option, only admin and not the voter. So clicking on start election, agree. It says that network is busy. So let's see, let's confirm and see. Let's retry. So since we are working with a test network, these are usually quite busy. So this can happen. Okay, we have one pending transaction. So let's wait and let me go and refresh it. Yeah, you can see all the candidates here. The Visaj candidate that we added, that is also visible. Now let's go to a voter's account, the voter that I added initially. Yeah, now I have the option to vote. So let's vote for Visaj and select vote. Confirming the transaction. Yeah, and the vote's done. Now let's go back to the admin account. So this is the live election tracking. So you can see Visaj has received one vote and the other candidates have. So now let's try voting again. So I'll show how you cannot vote twice. The same user cannot vote twice. Yeah, we are already seeing error messages. So I'll not be able to confirm this transaction. So that way we can see that it is not possible to vote twice. Now I'll go back to the admin page and let's end this election. Yeah, since the network is busy, it will take a while to confirm the transaction. We can see the final results. So Visaj got one vote and all the other candidates have zero. So again, since the test network is very busy, so the transactions going through can take a while, and that's why we are seeing this delay in the final results coming up. Yeah, so that is all for our product Voterboard. Thank you.